Swayam Prabha. Digital India. Educated India.
So, in this lecture we are going to talk about scientific temper in the 21st century, and we have seen over the last 300 years science has progressed so much and technology has progressed so much, they made a big difference to our life. So, what does one mean by scientific temper? We should really see how this is defined, and before we do that, I mentioned earlier also that we cannot talk of science and technology without talking of society, nor can we talk of society without talking of science and technology today. Society and culture on the one hand and science and technology on the other have become interpenetrating, mutually influencing forces. Society and culture, for example, provide support and legitimacy for science and technology activities, development of science and technological innovations. Science has become a force of production today. Scientific knowledge provides a basis for some technological innovations, and science is a force that transforms our consciousness about this world. In this sense, this is more important with respect to what we mean by scientific temper. Science is a force that transforms our consciousness about the world, and science is a secular knowledge. Science talks only about this world. So, it looks at relationship between phenomena in this world. So, what does one mean by scientific temper? It is Jawaharlal Nehru, the first Prime Minister of India, who is credited with the conception of the scientific temper. He said, "Future belongs to those who make friends with science." And he also said about scientific temper, the attitudes of mind which lie behind the method of acquiring reliable, practical knowledge may be called scientific temper. That is how he defined. He recognized the significance of science in removing superstitions and in transforming the consciousness of people. Science and technology were seen by him as important means to achieve economic and social development. The scientific policy resolution of 1958, prepared under his leadership, is an indication of the realization of the significance of science and technology. The 1958 scientific policy resolution aimed at securing all benefits arising out of the use of science and technology to the people of India. And also this policy resolution created a lot of scientific establishments, expanded the existing ones, and provided opportunities for young people of India to pursue education in science and technology. And today what we are is because of the foundations laid by the vision of Jawaharlal Nehru regarding the development of scientific and technological institutions. Nehru also said that the scientific temper goes beyond objectivity and fosters creativity and progress. So, I think Nehru was the one who visualized what scientific temper is and its relevance for countries like ours in achieving rapid progress and also in changing our understanding of the world, the universe. And later this through the 42nd amendment to the Constitution, Article 551A H, the idea of scientific temper has been incorporated into our Constitution. The Constitution, the article reads as follows: "It shall be the duty of every citizen of India to develop the scientific temper, humanism and spirit of inquiry and reform." This is enshrined in our Constitution now, so it is incumbent upon every citizen to really imbibe or internalize the idea of scientific temper and accordingly carry out his or her activities in daily life. In 1981, a group of intellectuals got together and they looked at the Nehruvian concept of scientific temper, and they said it has to be taken forward, it has to be really operationalized in terms of how does a common man use or sort of internalize this scientific temper. According to this statement, 1981 statement, which was really led by people like Huxer and others, eminent people, who drafted this statement. The statement reads as follows. So, I am going to quote from the statement. Scientific temper involves the acceptance amongst others of the following premises: that the method of science provides a viable method of acquiring knowledge, that human problems can be understood and solved in terms of knowledge gained through the application of the method of science, that the fullest use of method of science in everyday life and in every aspect of human endeavor, from ethics to politics and economics, is essential for ensuring human survival and progress. That, again I quote, that one should accept knowledge gained through the application of method of science as the closest approximation to the truth at that time, and question what is incompatible with such knowledge, and that one should from time to time re-examine the basic foundation of contemporary knowledge. Again, the 1981 statement says the scientific temper is compatible with observation and insight, reasoning and intuition, systematic work and creative impulse. It gives rise to an attitude of mind which, while being conscious of vast areas of ignorance, is nevertheless optimistic about human ability to gradually unravel the mysteries that surround us. In this process, scientific temper becomes a part of the culture, a philosophy and a way of life which leads to pursuit of truth without prejudgment. It means it creates an open-ended inquiries, possibilities for open-ended inquiry. And again, to quote from the statement, inherent scientific temper is a system of value judgments. The inculcation of scientific temper in our society would result in our people becoming rational and objective, thereby generating a climate favoring an egalitarian, democratic, secular and universalist outlook. So, this statement viewed that internalizing scientific temper, the values that go with it, the kind of outlook that it gives us to look at the world, the method it gives us to look at the world, will lead to ultimately egalitarian democratic society, and which is secular in its outlook and universalist outlook as well. In the sense, the scientific knowledge so far generated, I have been mentioning it in my earlier lectures, that it has really transformed our consciousness over time. For example, before 16th century, people across the world believed that Earth was in the center of the universe, but Copernicus, after Copernicus, people agreed that Copernicus proposed a theory that one should look at the world by placing sun in the center, not Earth in the center. So, in the geocentric theory of universe, the fact that the sun revolves around Earth is a fact, and in heliocentric theory of universe, the Earth revolves around the sun is a fact. So, these are two different ways of looking at the world. That's how our scientific knowledge transforms our consciousness. So, always sometimes religion and science are pitted against each other as if they are antithetical kind of belief systems. Science and religion are always seen as antithetical. Science is rational beliefs and religion is non-rational beliefs. Religion consists of non-rational beliefs. Scientific knowledge is based on evidence and logic. Religious beliefs are based on faith and revelation. We should recognize that both religion and science have been undergoing secularization. Religion from a blind faith to rationally weighed faith, science from religious moorings to differentiated culture and a secular culture. In the sense that earlier scientists, if you look at the 16th century, 17th century scientists, they said by studying nature, we are going to glorify the power of God who created this nature, this universe. It is in this sense, it is in these terms they placed their knowledge while they were pursuing scientific knowledge, and later on it became more and more secular. There were no references to the God. They started looking at phenomena in this world by relating to other phenomena in this world. Whereas religion still forms a very, very important part of our life. It provides still certain kind of a moral values to us, and it still gives certain kind of a code of conduct. And ultimately, religions, one should see that all religions, the purpose of all religions is to discipline is to discipline life of individuals. Now, if you understand in this sense, religion becomes more a personal kind of belief system, maybe held by a group, and this also should be seen as a basis for moral values. Of course, science itself can be seen as a source of moral values, because, as I said, the idea of equality can be seen from the scientific knowledge that has been generated about human genome. Human genome revealed that 99.9% of genome of all individuals in the world is similar, and that means all individuals in the world have a similar biological makeup, and in that sense they are equal. But all the differences that are produced, like differences in terms of class, caste and religion, are socially produced. So, I think in that sense science also transforms our value system and the way we look at the world. Morality and ethics. Our moral and ethical concerns are towards human beings. Morals can be evolved sometimes without reference to God, as Gautam Buddha said. That is, one can, by living together, one can evolve a certain code of conduct, certain code of moral principles, which really makes us live together. Science should be used to evolve new morals and ethics, and this is where there is always a kind of a tension between scientific science and, of course, religious beliefs. And also one should see that religion in today's context has become highly politicized. Each political group constructs a particular religion in its own way, although it may not be the real picture of religion that people have really have internalized. Now, on the front of the scientific knowledge, science today has moved from a morally neutral activity to an activity that is interested in patents and the consequent gains out of the patents. So, John Zeman observed that science has moved from a public resource, or science has changed from a public resource to an intellectual property. Change in ethos of science from conventional ethos of disinterestedness and skepticism, openness to profits, efficacy and secrecy. In the sense, the ethos of science have changed from conventional ethos of disinterestedness. In the sense, disinterestedness means that when I come out with a theory, I don't say that it is the final theory. I always place before my colleagues to see whether it makes sense or not. It is my colleagues, my peers who are going to evaluate my claims, and I don't have vested interest in my theories. Skepticism means I always suspend judgment about my claims, my theories, till final evidence is final evidence is gained, or my colleagues approve of what I said makes sense. And open science is an open-ended inquiry, and you never say that this theory is final, this theory is kind of final to explain every phenomenon. From this kind of a value system, it shifted to a value system based on profits, efficacy and secrecy, and we now talk of technoscience, which is interpenetration of science and technology, and a hybrid knowledge system linked to industrial and military interests. Scientific knowledge is protected by legal institutions as an intellectual property. The distinction between basic and applied science is no longer maintainable. For example, patenting the isolated pure genes, patenting of transgenic microorganisms is legally accepted, and they are granted patents. And that means nobody can use these genes, transgenic microorganisms, without taking permission from those who discovered these microorganisms or transformed these microorganisms or genetically engineered these microorganisms and the isolated pure genes. That means one has to pay to get access to these things. Science and democracy, spirit of inquiry and acceptance of the right to question and be questioned are fundamental to science. Again, it's a statement from the 1981 statement on scientific temper. In reality, there is an asymmetry. Scientists question the attitudes and behavior of people and deny the right to people to question science. So this is increasingly becoming a question now, that people are also asking questions whether scientists are, what scientists are saying are really true, or to what extent they are going to benefit people. People are asking such questions now. The right to question science also has to be granted. These rights also are fundamental to democracy. So everybody has a right to question in democracy. It's not only the scientists who can ask others questions, but others also can ask questions, pose questions to scientists. See, for example, there is a tendency among the scientists, all the traditional knowledge that the communities accumulated over time is irrelevant or ignorant. This is no scientific basis. That's not actually correct. Over centuries, communities have accumulated knowledge about nature, knowledge about plant life, animal life, and also the plants can be consumed as food, which plants cannot be consumed as food, and so on. The secular traditional knowledge accumulated by communities over time through their empirical experience and trial and error methods is an important corpus of knowledge. That's why the Convention on Biological Diversity of the United Nations recognizes traditional knowledge, clause 8J and 15, and the Government of India is signatory to the CBD, and also the Government of India, the legislature ratified this CBD, and India is trying to implement some of the recommendations of the Convention on Biological Diversity. Another example is the ICAR, Indian Council of Agriculture Research, surveyed about 140 traditional agriculture practices and found that 90 of them are scientifically sound. That means all our traditional practices cannot be dismissed as irrelevant or saying that they have no basis. But ICAR proved that out of 140 traditional agriculture practices, 90 of them are scientifically sound. They are as scientific as modern science. The scientists they're as scientific as they conform to the modern science standards. Okay. And knowledge of social actors. Social actors are thinking beings. They are of a creative. They also are creative and reflexive. They not only react to situations but also create new situations. This has to be the premises of interaction between scientific community and science communicators on the one hand and people on the other. That is, people, by being creative, they can ask questions. For example, the whole debate about genetic engineering of food, genetically modified food, people are raising questions. Is it safe to consume? How long it's going to be safe? And whether it's going to affect our environment, farming systems, and so on. They are asking questions, and these questions have to be answered. Scientists cannot say that these are irrelevant questions. People's knowledge. Communities have developed understanding of environment and evolved norms regarding use of resources from the environment according to some norms. For example, identification of useful species, cultivating them, breeding and conserving them in situ. For example, if you go to northeast, there are at least 70 species of bamboo which have been conserved by the communities in the northeast. The tribal communities in the northeast. That's a big kind of a conservation effort. People have really conserved 70 species of bamboo. Similarly, artisans, handloom weavers and handicrafts, they all have knowledge of the dyes, knowledge of the behavior of the yarn, knowledge of the behavior of what cotton to use to make what kind of clothes and so on. People examine modern science and technology from the vantage point of their lived experience, lived experience of everyday life, the impact of science and technology on health, food and environment. People are now asking questions. So, scientific temper as an interface, it can be seen the scientific temper should sensitize people to evaluate scientific approach vis-a-vis other approaches they are familiar with. By privileging science, we have marginalized other knowledge systems. Society and science should question each other in line with democratic principles of openness, an enabling democratic institutional environment in which citizens can question and make creative interventions in various domains of knowledge production has to be created. This is what we mean by participatory innovation, and people should be involved right from the beginning of the innovation so that they contribute to their knowledge to the ultimate result of the innovation. So basically, this need for reasserting the scientific temper arises because a lot of distrust has developed on science among people. See, for example, the distress was because of certain developments which the scientific knowledge, the way in which scientific knowledge was used, and certain technological artifacts that have started impacting the societies. In Europe, members of the civil society questioned the usefulness of some of the modern science-based technologies. The mad cow disease was a consequence of a decision by a scientific community. Another example is genetically modified food. See, for example, we all are familiar with mad cow disease, which affected several cows, and these cows had to be culled in Britain. In the US, genetically modified food is not distinguished from food produced by hybrid seed, so they don't see any difference between GM food and food produced by other kinds of methods. In India, we have imposed, as I said, moratorium on brinjal, genetically modified brinjal. And so after the moratorium was imposed, the Minister for Environment and Forests asked scientific academies in India like INSA, Academy of Science in Bangalore and so on, to carry out further tests and give the reports. They have submitted a report which basically was not done on the basis of original research, and the minister said said that he wanted original research reports. So again, because of the developments of new technologies, new sciences, some group of people felt the need for revisiting this 1981 statement. In the context of changes that have occurred since 1981 due to advances in scientific knowledge in different areas such as modern biology, biotechnology, information technology, and the changes in the political climate, a group of intellectuals realized the need to revisit the statement of 1981 and evolve new strategies for spreading scientific temper. A workshop was organized at Palampur, Himachal Pradesh in 2011 to review the statement, 1981 statement. The workshop acknowledged the spirit of the 1981 statement and concluded that scientific temper is relevant today and proposed some of the strategies to propagate scientific temper. This declaration says, this is all quotation from that declaration, it is imperative to make relevant scientifically generated latest information available to the common citizen. However, it will be erroneous to equate scientific temper with scientific information. It has been repeatedly observed that through a survey studies that the structure of a common citizen is constituted by structure of thought. It should be the thought structure of common citizen is constituted by scientific as well as extra scientific spaces. These two mutually exclusive spaces coexist peacefully. That is basically trying to say that science on one hand, scientific knowledge on the one hand, and religious beliefs on the other. Act of invocation of one or the other is a function of social, political or cultural calling. Those who consider spreading scientific temper as their fundamental duty must aim at enlarging scientific spaces. We call upon the people of India to be the vanguard of scientific temper. Further, the declaration says, use of religious symbols and ceremonies with religious overtones performed in the garb of cultural activities must be discouraged or stopped in government offices and institutions run with public funds. A national monitoring system with powers to issue guidelines must be set up to continually monitor for unscientific content in media channels and the education system, particularly up to school level. Scientists and scientific institutions only function in a more, should not only function in a more transparent manner, but also reach out to the public at large with an objective to instill confidence in science, scientists and scientific institutions. Further, it says more of a practical kind of intervention. It says a television channel dedicated to the spread of scientific temper should be operated with funding from the government. Science communication activities mandated in the government agencies should focus more on rationality, inquiry and method apart from the content. It says India is a stratified country or society, and cultural and religious minorities have special needs. Fundamentalist, unscientific, antiquated ideas are not prevalent only among religious majority. These are also as rampant among the minority and marginalized sections of people. So this is the declaration, and I said this is very, very important in the context of controversies that we see today about genetic engineering, genetically modified food. People should be able to question the scientists regarding safety and the health benefits or of the genetically modified food, to what extent they are going to and what extent GM food can be consumed, whether or not it can be consumed, and so on. These questions have to be answered. So I think to understand this, to do this, as I mentioned, the Palampur statement also mentioned that there must be a dialogue between scientists and common people. This calls for interactive learning between practitioners of science on the one hand and members of the society on the other. The scientific community should admit that scientific knowledge is tentative at a given point in time. Scientists should always say that at this point this is what we know, beyond this we do not know, but ours is not ultimate truth. But there is a tendency among the scientists to say that what we know is the ultimate truth and you all have to accept it. Right. So the idea of tentativeness, the idea of science being a open inquiry has to be accepted even by scientists, some of them who really believe that they arrived at the truth, ultimate truth. So cognitive empathy as a methodological heuristic is useful to understand the problem from the point of view of the other, to evolve shared perspective. Then science and society can co-evolve by socializing each other. Example, participatory innovations, participatory plant breeding, that is developing new plant varieties, and empirical studies on the spread of scientific temper, data on the extent of scientific temper. One has to really collect data on the extent of scientific temper to devise schemes and programs to promote scientific temper, operationalize the concept for large scale quantitative statistical sample surveys, or and also qualitative studies that capture the scientific temper through depth interviews of a representative fraction of the population in the survey has to be conducted, or it can be a totally kind of a qualitative study, ethnographic study of how people interpret science, how people interpret scientific knowledge in their own terms. Their narratives of problems and solutions they developed should be recorded. In the sense, the third kind of the ethnographic approach will give us an idea of the world from the actor's perspective, give us an idea of how they interpret the scientific knowledge claims, how do they interpret certain technological interventions from their point of view, because they are relevant social groups, because ultimately the scientific knowledge and technological artifacts are going to affect their lives. So it is very important to engage them in dialogue. Now as a sociologist, I would like to mention how the values, attitudes and action are related. See, values and meanings, when you talk of, for example, the value of openness, the value of democracy, these are all values which we try to translate them into our practice, right. As I said, science has certain values of openness, of democracy of accepting the failures and so on, and these are important values, and they create certain attitudes among people. That is, attitudes are our dispositions towards objects, events, practices, and certain knowledge claims or certain artifacts. Like how does one look at, for example, a technological artifact? What is his attitude towards a technological artifact, or what is his attitude towards or her attitude towards a scientific knowledge claim? Attitude means that whether you approve of a particular claim or disapprove. This is based on your value system. For example, does one approve of large scale felling of trees for timber, for extracting timber? So, it is a question. So, if people hold that the trees are important, they are going to be useful for our life, then they will not allow felling of trees for purpose of timber. So, these are environmental values where they recognize the importance of the trees. And following from these attitudes, action follows. As I said, if somebody says that trees are going to be useful for their agriculture, their climate and so on, they will try to see in their action to prevent any kind of deforestation or felling of trees. So, this is what we mean by the relation between values, meanings, attitudes and action. These are very dynamic relations. Sometimes actions also can lead to creation of new attitudes and new values. Okay. So, sometimes even if one is positively disposed towards a particular kind of values, a particular kind of action, this action may be prevented by the intervention of several intervening variables or forces. Okay. So, even if the communities want to protect environment, want to protect the tree cover in a given area, the powerful sections of the society perhaps may not really allow these people to protect this tree covers and so on. They may exploit them for the economic benefits. So, there is always a clash of interests sometimes when we really look at how the resources that are available in nature are going to be exploited, who is going to exploit it, and whether or not these resources that are exploited will benefit the local communities. So, I said this is the kind of relationship one should really understand, the dynamic relation between values and action. And how do we look at education and scientific temper? For example, education is the one which really is an activity of creative engagement with everything. That is how we define education, or critical engagement, critical and creative engagement with various things. Our school education system has to inculcate scientific temper by develop a spirit of questioning, to make observations, to apply logic to the claims that they are asked to accept, teach religion, to appreciate the difference between religious beliefs and scientific beliefs, and perhaps then they would really see where exactly, how exactly to make use of these belief systems in their lives, and what are the consequences of following one set of beliefs and then not following the other set of beliefs. Okay. So, I think the education system also must make learners to internalize the following values: originality, democracy, humility, justice and plurality. Originality is to encourage people to do new things, novel things. Science is all about doing new things, proposing new theories, proposing new kinds of hypotheses, and technology means producing original new artifacts, new kind of innovations. Democracy means respecting the other, trying to engage in dialogue with others to arrive at a solution. Humility means to admit that I do not know certain things, right. If you admit that I do not know certain things, one can learn. On the other hand, if you say if you don't have humility, you say that I know everything, that's the end of learning. So nobody can learn anything whoever says that he has already or she has already learnt everything. Plurality means that there are different ways of looking at the world, different ways of looking at the problem, and this has to be respected, and different ways of looking at problem will also lead to different solutions. So this has to be the learners have to internalize these values, and that's how you can make young students, young learners, when they grow up, they develop this outlook of being open-minded, learn to respect others, and also have humility, and that means they would be interested in learning more and more. So that's how they will contribute to the nation building, contribute to the economy and cultural development of the country. Thank you very much.